dear friends, welcome to yet another session of Mission Banker. Yes, it's been a long since we discussed something for entrance examinations, isn't it? Yes. So in this session we are going to discuss something for our entrance examination, and we are going to discuss some of the very important topics or concepts discussed in the very first chapter of physics paper. The topics that we are going to discuss from this session onwards are very important from entrance examination point of view than the topics that we discussed earlier, like parallax method or applications of parallax method or problems on parallax method, etc. We could find questions, we could find more questions asked from these sections that we are going to discuss from this session onwards. We could hardly find questions from the sections that we discussed earlier. Yes, so there are three more topics to be discussed in this chapter, and they are errors, significant figures, and dimensional analysis. Among these three topics, we can say dimensional analysis is very important. We can say we couldn't find even a single question paper without questions from dimensional analysis. Even though the other two topics like errors and significant figures are not as important as dimensional analysis, it's still important. So in this session we are going to discuss something about errors. Yes, shall we move on to our session? Let's start our session. So as I told, three topics, errors, significant figures, and dimensional analysis are very important. And among these three topics, yes, dimensional analysis is the very important topic, and it is the very last topic of this chapter. Yes, now let's see something about errors. Before going deep into error, first let's understand the three terms which we usually or which we always hear in measurements, that is accuracy, precision, errors. Yes, accuracy, precision, errors. So let's start with accuracy. What is accuracy? What is the meaning of the word accuracy? Accuracy means correctness. So then what is accuracy in measurements? Let's try to understand it through an example. Yes, we know any physical quantity which we are measuring will have an actual value, isn't it? Suppose this marker will have an actual mass, or this marker will have an actual length, isn't it? Yes. Likewise, any physical quantity which we are measuring will have an actual length. Here in this example, I am considering the length of this particular marker. I am going to consider the length of this particular marker, and I am assuming, or let it be 15 centimeter. The actual length of this particular marker be 15 centimeter. Yes. Now, using a measuring instrument, I am going to measure the length of this particular marker. Using a measuring instrument, I am going to find the length of this particular marker. I repeated the experiment. I repeated the same experiment for some 5 to 6 times, and I got different values like 14.9, 14.8, 14.8, 15.2, 15.3, again 14.86. yes, here I repeated the experiment for some 6 times, and I got some different values. Yes, so which is the most accurate value? Among all these measurements? I am saying 14.9. 14.9 is the most accurate value. Yes, but how come? How do we find the most accurate value from a given set of measurements? Yes, let's see. It is very easy to find the most accurate value from the given values, because the most accurate value is nothing but the value which is much closer to the actual value. So the most accurate value among all the given measurements is nothing but the much closer value to the actual value. So how do we find which value is much closer to the actual value? We simply find the difference between those two values. We simply find the difference between those two values. Here I am going to find the difference between the actual value and the measured value in all the cases. So in the first experiment I got 0.1. minus 0.1, minus 0.2, minus 0.2, plus 15.2 means plus 0.2, and here plus 0.3. Yes. Here we have to remember, here while finding the most accurate value among a given set of measurements, here we have to remember an important point, that is, here we'll only consider the magnitude of the difference. We never consider the sign of the difference. Is it clear? Here while finding the most accurate value among a given set of measurements, we should remember an important point, that is, while finding the most accurate value, yes, we'll only consider the magnitude of, we'll only consider the numerical value or the magnitude of the difference between the actual value and the measured value. We'll never consider the sign of the difference. Is it clear? Yes. So either the sign can be positive or it can be negative. No matter, we just consider the numerical value. We just consider the numerical value. So here this minus or plus is not needed. Here this minus or plus is actually not needed. We just need the numerical value. Among all these values, I have to find the smallest value, and it is very clear that 0.1 is the smallest difference. 0.1 is the smallest difference among all these values. So the value having the smallest deviation, or smallest difference is the much closer value to the actual value. So that value is the most accurate value. Is it clear, guys? Is it clear? Yes. So here in this case 14.9 is the most accurate value. Again I am repeating the same experiment once more, and I got the value as 15.1. I got the value as 15.1 and I am asked to find the most accurate value. Yes, here in this case again I am going to find the difference between the actual value and the measured value. It is 0.1 and this is 0.14, isn't it? 0.14. This is 0.14 and this is 0.1. Yes, again, which is the most accurate value? I am saying 14.9 and 15.1. These two values are the most accurate value among all these values. Why? Two values, because these two values are much closer to the actual value. These two values have a common deviation or have same deviation, isn't it? These two values have same deviation. Is it clear? Yes, the degree of closeness of these two values to the actual value is one and the same. No matter the difference between 14.9 and 15 centimeter is minus 0.1 and the difference between 15.1 and 15 centimeter is plus 0.1. Yes, as I told you before, we will never consider the sign of the difference. We will only consider the numerical value of the difference. Yes, the magnitude of these two differences are one and the same. So we can say these two values are the two most accurate values among the given values. Is it clear? Accuracy of a measurement? Yes. Yes. So now let's see what is precision. Yes. Here in precision we have two cases. The first case is precision of an instrument, and case 2 is precision of a measurement. So first let's see what is precision of an instrument. Suppose I have an instrument, measuring instrument A. I have a measuring instrument A. I have a measuring instrument A. Here in this instrument I am considering two adjacent values, any two adjacent values. Here I am considering 1 and 2. Yes, you can consider any two adjacent values, that is 1 and 2 or 5 and 6, likewise any two adjacent values. Yes, here I observed that between these two adjacent values there are 10 divisions, 10 equal divisions. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yes, between these two adjacent values there are 10 equal divisions. Yes, I want to find the measure of this single division or measure of each division. Yes, so how do we find the measure of each division, or how do we find the measure of a single division? Yes, it's very easy. I know the measure of this whole 10 division is actually the difference between these two adjacent values, isn't it? Yes, the measure of this whole 10 division is actually the difference between these two adjacent values, that is 2 minus 1. Yes, this total measure is actually the measure of 10 divisions, and I am asked to find the measure of single division, so I have to simply divide it by 10. So I will get 1 divided by 10, that is 0.1, isn't it? Yes. So after each division, a value of 0.1 will be added to the previous division, isn't it? Yes, that is, this division is 1. So the next division will be 1.1, that is 1 plus 0.1. A value of 0.1 is added to the previous division value to get the current division value. So it is 1.1. Again 1.1 plus 0.1 we will get 1.2. Again 1.2 plus 0.1 we will get 1.3. Likewise it goes on like this. 1.7, 1.8, 1.9, and the 10th value is 2. Yes, is it clear? Yes. Now if suppose I am measuring the length of a box. Okay, I am measuring the length of a box. Say the length of the box is 1.6. The length of the box is 1.6. So I will get a value, or I will get the measure as somewhere here, isn't it? Yes. Now suppose I am measuring the breadth of this box. I am measuring the breadth of the box having a breadth 1.672. 1.672. Yes. Could I measure the breadth of the box exactly using this instrument? Could I measure the breadth of the box? Could I measure the breadth of the box exactly using this particular instrument? No. If I measure the breadth of the particular box, yes, I will get to the measurement somewhere in the middle of 1.6 and 1.7. Isn't it? If I am measuring the breadth of a box having actual breadth as 1.672, using this instrument I'll get the measurement as between some 1.6 and 1.7. So I can say the breadth of this particular box lies in between the range 1.6 and 1.7. So actually I could find only the range of that particular value or that breadth. I couldn't find the exact measurement of this particular breadth of the box, isn't it? Yes, using this instrument A. So why is it so? It is because using this particular instrument we could measure only exact values up to 1 decimal place. Why is it so? It is because the measure of a single division is 0.1. The measure of a single division is 0.1. So we could only measure exact values up to 0.1 or up to 1 decimal place. Is it clear, guys? That's why we couldn't measure. We couldn't measure the exact values. We couldn't measure the exact values having decimal places more than 1 using this instrument A. Now let's consider another instrument B. Here in this case also I am considering 2 adjacent values. Yes. So B is not like A. In A we had between these 2 adjacent values we had 10 divisions. But in B we have 100 divisions between these 2 adjacent values. Between any 2 adjacent values, yes, It goes on like this. We have 100 divisions. Yes. Here again I have to find the measure of a single division. We know the total measure of 100 divisions is nothing but the difference between these two values, that is 2 minus 1. So what is the measure of single division? We know the measure of 100 division is 2 minus 1. So what is the measure of a single division? Just divide 2 minus 1 by 100. So we will get 0.1. Yes. So to get the next value, division value, we just add 0.01 to the previous value. So here it is 1, 1. So the next value will be 1.01. We are adding 0.01. In the previous example, we added 1 plus 0.1 because the value of each measure, the measure of each division was 0.1. But in this case, the measure of each division is 0.01. So we have to add 0.01 to each measurement or each division to get the next value. Yes. So this is 1.01, 1.02, 1.03. It goes on like this, and somewhere here we will get 1.90, 1.91, 1.92. It will goes on like this, and finally we will get 1.9, and the 100th value is 2. Now I am going to measure the breadth. The breadth or length of a box, breadth of a box having length 1.67, yes, I can find the exact measurement, isn't it? In this case, I can find the exact measurement because here using this instrument I can measure exact measurement up to 2 decimal places because the value of or the measure of each division is 0.01. If suppose it is given the length of a box is 1.6, can I measure this value exactly? Yes, I can measure the value exactly because up to 2 divisions using this instrument B, yes, I can measure exact values having no decimal places, having 1 decimal place and having 2 decimal place. Can I measure exact values having 3 decimal place? No, it is not possible because the measure of each division is just 0.01. If it was 0.001, that is if there were 1000 divisions between these any 2 adjacent values, using such instruments we can measure a maximum number of decimal places up to 3. Is it clear, guys? Yes. So what is the precision of an instrument? Precision of an instrument is nothing but it is the maximum number of decimal places up to which a physical quantity can be measured exactly. So if suppose it is given the precision of an instrument is 0.001. The precision of an instrument is 0.0000001. So what does it mean? It means using this particular instrument we can measure the value of physical quantity exactly up to 5 decimal places. What does it mean? It means we can measure exact values of having 0 or no decimal place, 1 decimal place, 2 decimal place, 3 decimal place, 4 decimal place and a maximum of 5 decimal place. Is it clear, guys? Precision of an instrument? Yes. So as the precision of an instrument increases, we can say as the precision of a measuring instrument increases, we will get more accurate values. Say for example, I know the actual length of this marker is 15 centimeter. I know the actual length of this marker is 15 centimeter. I am using instrument A. To measure the length. and I got some value as I got the value somewhere in between 14.9 x less than 15. I got the value somewhere in between 14.9 less than x less than 15. So I can say the value is in the range 14.9 and 15. Suppose I'm measuring the length of this marker using the second instrument B, then I will get the value as 14.96. Maybe I am getting the value as 14.96 because using this second instrument I can measure the exact value up to 2 decimal places. So I got 14.96. Which value is more accurate, 14.9 or 14.96? How do we find the most accurate value? We simply calculate the difference, isn't it? So the difference between 14.9 and 15 is 0.1. The difference between 14.9 and 15 is 0.1, and the difference between 14.96 and 15 is 0.04, isn't it? 0.04. So which is a lesser value, 0.1 or 0.04? Obviously 0.04 is the smaller value. So we can say 14.96 is the most accurate value among these two values. And which is the most precise value among these two values? Again, 14.96 is the most precise value because there are 2 decimal places. In the first one, 14.9, yes, we have only 1 decimal place, and in the second value we have 2 decimal places. So we can say 14.96 is the most precise value. So as the precision of the instrument increases, as the precision of, you listen to the point, as the precision of the instrument increases, we can measure or we will get more accurate measurements. Is it clear, guys? Yes. So now let's understand what is precision of measurements. Yes. So what is precision of measurement? Yes, I'm measuring the length of this particular marker. I repeated the experiments for some 7 to 8 times and I got different values: 14.9, 14.8, 14.8, 14.76, 14.76, 14.76, then 15.1, 15.2, 15.19. So 4, 6, 9, there are 9 values and I have to find the most precise value. Let this be 15.1. I have to find the most precise value among these given measurements. I am saying 14.76. 14.76 is the most precise value among these measurements. And how come? Yes, when the most precise value, yes, when we are considering the precision of an instrument, the value having more number of decimal places, is the most precise value. Yes, while considering the precision of an instrument. But while considering the precision of measurements, the most repeated value is said as the most precise value. So in this case 14.76 is the most repeated value and this value is the most precise value. Sometimes the most precise value can also be the most accurate value, but it is not the case always. Is it clear? Yes. So what is precision of an instrument and what is precision of measurements? Is it clear, guys? Yes. Now let's see what are errors. Yes. So as I told, any physical quantity which we are measuring will have an actual value, isn't it? Any physical quantity which we are measuring will have an actual value. Yes, suppose the actual value of the length of this marker is 15 centimeter. Yes. So I am measuring the length of this marker using some measuring instrument. There are there are 3 possibilities. Either the measured value will be equal to 15 centimeter. Either the measured value will be equal to 15 centimeter or the actual value, or the measured value can be less than 15 centimeter, or the measured value can be greater than 15 centimeter. If first one is the case, then we can say there is no deviation. There is no deviation from the actual value to the measured value, isn't it? Yes. If the case is second, yes, we can say there is a deviation from the actual value to the measured value in negative direction. Because when value is less than 15 centimeter, yes, when we find the difference between these two values, yes, we will get negative sign in the difference. Again, if the measured value is greater than 15 centimeter, yes, then the deviation in positive direction, yes. So, no matter whether the deviation is in negative direction or in positive direction, we can say there is a deviation. So if there is a deviation to the measured value from the actual value, then we can say there is an error. So what is error? Error is nothing but the deviation to the measured value, deviation of the measured value from the actual value. Is it clear? Yes. So how do we find the error? In a measurement? Suppose I'll give you some exact values. For 15 centimeter, when I measured the length of this marker using an instrument, I got the measurement as 14.896, and I wanted to find the error in this particular measurement. So how do I find 14.896 minus 15? 14.896 minus 15, so I will get minus 0.104. So the error in this particular measurement, is minus 0.104. Yes. Suppose when I measured the length of this marker, I got the value as 15.267. So what is the error in this measurement? The error in this measurement is 15.267 minus 15, that is equal to 0.267 plus 0.267. So the first value is deviated. The deviation of the first value is by 0.104 in negative direction, and the deviation of the second value from the actual value is by 0.267 in positive direction. Is it clear, guys? Yes. If I am getting the value, if the measured value is exactly 15 centimeter, then I can say 15 minus 50 is equal to 0. So no error. Is it clear, guys? Yes. Accuracy, precision and error. So while finding the most accurate value, or while finding the most precise value, or while finding the errors in measurements, in all these cases, we have to consider not only the value of measurement but also the unit of measurement. Yes, sometimes just to confuse you guys, they may give values in different units and you will be asked to find the most accurate value or the most precise value, or else the error of a measurement likewise. Yes, let's discuss some simple example problems on accuracy, precision and error. After that, let's move on to the next topic, that is types of error. Yes. So here I am going to consider the mass of an iron ball, and the actual mass of this particular iron ball is, say, let it be 50 kilometer. It's not kilometer, kilogram. Let it be 50 kilograms. So I am going to calculate, or I am going to measure the mass of this particular iron ball using a measuring instrument, and I repeated the same experiment multiple times. So I got different values. Let the value be 48.8 267. Okay, 267 kilogram. 49.968 gram. Okay. 51.623 kilogram. Again, 50.968 gram. Okay. The next one is 50 mu gram. 50 mu gram. Again, okay, 50,000 1 gram. 50,000 1 gram. Okay. Here in this case or in this question, I have to find the most accurate value. In this question, I have to find, you are given some 2, 4, 6 values and we want to find, or we are asked to find the most accurate value. Yes. Here we can see that the value, the actual value is given in the unit kilogram. The actual value is given in the unit kilogram, and the measured values, some of the values are given in kilogram, some are given in gram, and some others are given in mu gram. So in such cases, you have to either you have to convert all the given values into kilogram, all these given values into kilogram, or else you have to convert all these given values in any other particular unit. It can be gram or mu gram. Is it clear? Yes, either you can convert all the measured values, all the units of the measured values into kilograms, that is the unit of the actual measurement, or else you can convert all the values in kilogram into some other units. Say it can be gram, it can be mu gram, or any other unit. Anyways, the units of all these measurements, the unit of all these measurements should be one and the same while we are finding the error, or we are finding the most precise value in the given measurements, or we are finding the most accurate value. So the first one is given in kilograms, so there is no need of converting, isn't it? The second one is given in gram. So I need to convert this particular value into kilogram to know, yes, is this the most accurate value or not? Yes, we know 1000 gram is equal to 1 kilogram, isn't it? 1000 gram is equal to 1 kilogram. So what is 1 gram is equal to? 1 gram is equal to 10 power minus 3 kilogram. 1 gram is equal to 10 power minus 3 kilogram. Yes. So here I have to calculate 49.968 gram. I have to find what is 49.968 grams in kilogram. So I have to simply multiply for 49.968 into 10 power minus 3 kilograms. So this value becomes 0.049968 kilogram. 0.968 kilogram. Is it clear? Yes. So if you have any doubts, in conversion of units, yes, we have done a detailed session. For units and their conversions. Yes, please go and watch those sessions. Yes, you will get a clear-cut idea. Yes, so the second value we got is 0.049968 kilograms. Suppose if this value is given in kilogram unit, we can say the second value is more accurate than the first value, isn't it? Because the second value is much closer than the first value. But here in this question, yes, it is given in grams. So is it clear, guys? Yes. Why should I tell you? Why should I tell you? We should consider the units also. Not only this values, we should consider the units also while finding accuracy, precision or errors. Is it clear? Yes. Now let's see the next value. It is given in kilogram. Again here also the value, the fourth value is given in gram. So I have to find in kilogram. The value will be 0.050968 kilogram. 0.0968 kilogram. Again this particular value 50 mu gram, this value is given in mu gram. So here I have to find the value in kilogram. I know 1 gram is equal to 10 power 6 mu gram. Sorry, 1 mu gram is equal to 10 power minus 6 gram. 1 mu gram is equal to 10 power minus 6 gram. And I know 1 gram is equal to 10 power minus 3 kilogram. 10 power minus 3 kilogram. So what is 1 mu gram is equal to 10 power minus 6 into 10 power minus 3 kilogram, that is equal to 10 power minus 9 kilogram. 10 power minus 9 kilogram. So here what I will get, 50 into 10 power minus 9 kilogram. If suppose this value was, instead of mu gram it was given in kilogram, we can say this is the most accurate value, because the measured value is exactly equal to the actual value. But in this case it is given in mu gram, so we cannot say this is the exact value or this is the most accurate value. Again the last value is given in gram. Here we have to convert the given value into kilogram. Yes, 1000 gram. 1000 gram is equal to 1 kilogram. So 1 gram is equal to 10 power minus 3 kilogram. So what is 50,001? 50,001 kilogram, isn't it? Yes. So 501 into 10 power minus 3 kilogram, that is equal to 50.001 kilogram. So we got the last value as 50.001 kilogram. Now after converting all the units, after converting all the values into single unit of your choice, here I converted all the given values into kilograms. Is it clear? Yes, after converting all the given values into a single unit of your choice, then you can find the most accurate value. So here in this case we can say the most accurate value is 50.001 kilogram, isn't it? 50.001 kilogram. So the last value is the most accurate value among all these given values. Is it clear? Yes. Yes. Next example. Here in this case, I am provided or I am given some values. and here I am asked to find the most precise value considering the precision of measurement, not the precision of instrument. Yes. I am given some values as 99.76 meter. Okay. 98.67 centimeter, 0.9867 meter, 986.7 millimeter. Again 99.76 centimeter, 99.76 millimeter, 92.878 kilometer, 92.978 mu meter, 99.876 gigameter. Okay, and here I want to find the most repeated value, most precise value among these measurements. Yes, here how do we find the precision, how do we find the precision of the measurement, or how do we find the most precise value from among the given measurements? Yes, so here in this case also we have to first analyze the given values. First we have to analyze the given values and check. Here we have two measurements, isn't it? 99.76 meter and 99.76 millimeter. Even though the numerical values of these two values are same, the units of these two values are not same. The numerical value of these two values or the magnitude of these two measurements are same, but the units of these two measurements are not same. One is in meter and the other one is in millimeter. So we can say these two values or this particular value is not the precise value, isn't it? Yes. So we can reject or we can eliminate these two values from our list. Next, I am considering this number 98.67. 98.67, I am analyzing all these measurements. And I found in two of the other measurements, the numerical value is not exactly the same. In two of the other measurements, the numerical value is not exactly the same as 98.67, and the units are also not same. But the numbers or the digits in this particular measurements are same. That is 9867. Again 9867, again 9867, isn't it? The digits are same. Even though the numerical value is exactly not the same and the units are also exactly not the same, the number or the digits in each measurements are same, isn't it? So there is a possibility of this particular value being the precise value. Let's see. Here this particular measurement is given in centimeter, but in the second case it is given in meter, and the third one it is given in millimeter. So we have to convert all these three values into a single measurement. Anyway, here I am going to convert all these values into centimeter. Okay. The first value is given in centimeter, so no need of converting it. The second value is given in meter, so I have to convert into centimeter. I know 100 centimeter is equal to 1 meter. So what is 1 meter, isn't it? So what is 0.9867 meter in centimeter? Simply multiply by 100. That is equal to 98.67 centimeter. 98.67 centimeter. So this value I got as 98.67 centimeter. Yes, and the third value is 986.7 millimeter. I know 10 millimeter is equal to 1 centimeter. So what is 1 millimeter is equal to into 10 power minus 1. 1 millimeter is equal to 10 power minus 1 centimeter. So what is 986.7 millimeter in centimeters? It is nothing but 98.67 centimeter. Again I got the same value, 98.67 centimeter. Yes. So this particular value 98.67 centimeter. Yes, I got the same measurement, same value for 3 times. It can be the most precise value. Yes, let it be in the list. Yes, let these values be in the list. So now let's analyze the remaining values. Already we have eliminated 2 values here. Yes, these 3 values or this particular value 98.67 centimeter is under consideration. We have not yet eliminated. It has repeated for 3 times. If we get any other value which has repeated more than 3 times, if we get any other value which is repeated more than 3 times, then we can eliminate the value 98.67. Otherwise, yes, we have to consider this value. This particular value is under consideration now. Now let's see the next value. It is 90. Okay. Here we have 99.76. Okay, the value is different. The value is same but the unit is different. So we can eliminate this value also. Isn't it? 99.76. Again in this case, yes, if we observe, even the values are not same. Values are not same and the units are also not same. Here in this case, in these three cases, the values are not same and the units are also not same. Now I am checking whether the digits are same or not. Whether the digits are same or not. Yes, the digits are also not same. Here in this case, everything is different. Value is different. Unit is different. I mean exact numerical value is different, unit is also different, and also the numbers or the digits in each value is also different. So we can eliminate all these values. So which is the most precise value among the given values? 98.67 centimeter is the most precise value. This is how we find the most precise value from a given set of measurements. Is it clear, guys? Yes. Yes. Now let's see next example. Manu, not Manu, fed up of the same name, some other name, Binoy. Binoy measured, not measure, okay. Binoy measured the length of a room using an instrument having a precision of 0.0001. Yes. Okay. Some measurements for some 6 to 7 times. Yes. Here you are given some measurements. Here you are given some measurements. Which among the following given measurements are the possible exact values measured using this possible exact values, not measured, possible exact values obtained using this instrument. Okay. And the values are 9.678, 8.96, 8.54912, 2.97849, 8, 3.5, 3.804, 0.96785. Again one more value, 10.96785. One more value, 0.9678. Okay. Here you are given some 3, 4, 5, 6, 7. Here you are given some 10 values. Yes. And you have to find the possible values or possible exact measurements you got or you obtained using this instrument. Yes. So let's see what the question is. The question is given that Binoy measured the length of a room. Binoy measured the length of a room using an instrument, and it is given the precision of the instrument is 0.0001. 0. After point we have 4 digits. So what does it mean? It means using this particular instrument, we could measure the exact values or exact measurements up to 4 decimal places. So it can be no decimal place, isn't it? No decimal place, 1 decimal place, 2 decimal places, 3 decimal place, and a maximum of 4 decimal places. So which among the following you are asked to find which among the following given values, yes, the possible exact values or exact measurements obtained using this particular instrument. So values having decimal places up to 4, values having decimal places up to 4 are the possible values, are the possible measurements obtained using this instrument. So no decimal values with no decimal places is possible, values with a single decimal place is possible, values with 2 decimal places, 3 decimal places, and up to 4 decimal places are possible. All values having decimal places greater than 4 are not possible here in this case, because using this instrument we could measure the exact values up to 4 decimal places. All the other values we could only find the range of the value, is it? We couldn't find the exact value. Yes, we just discussed it. Yes. So here in this case 9.678 is possible, 8.96 is possible. Here we have 5 decimal place, so it is not possible. Here also we have 5 decimal place, so it is not possible. 8 is possible, 3.5 is possible, 3.804 is possible. This value is not possible, this value is also not possible, and this value is possible. Yes. All the circled values are the possible values, possible exact values obtained using this instrument. Is it clear, guys? Precision of an instrument. Yes. Is it clear? Yes. Now let's see an example problem for error, and then let's move on to the next topic. Yes. So the actual value, the actual mass, or we can use any other physical quantity, the actual current flow in an experiment, we got it as 12 ampere. Okay. The actual current or the current flow in a circuit is 12 ampere. Yes. So here I measured the current flow using an ammeter, and I got the value. I got some values as 11.96. Okay. 12.842, 11.9679, 12.096, and I am asked to find the error in each of these measurements. Yes. So how do we find the error in measurements? The error in measurements is actually the difference between the measured value and actual value. So error in this particular first case is 11.96 minus 12. So what is the value? 12.04, isn't it? 0.04 is the error. Here you have to put a negative sign. Yes, because 11.96 is less than 12. Again 12.84. What is the error in this measurement? 12.842 minus 12, that is 0.842. Here we got positive error because the measured value is greater than the actual measurement. Again here in the next case the value is less than the actual measurement, so definitely we will get a negative error, so minus 0.0321. And in the last case the value is greater than the actual value, so we will get a positive value 0.096. This is how we find the error in the given measurement. For finding the error in a given measurement, yes, we need to know the actual value. For finding the error in a given measurement, yes, we need to know the actual value of the physical quantity. By finding the difference between the measured value and the actual value, yes, we can find the error. Suppose in the examination they are asking you, they are asking you to find the errors in the individual measurement. You are asked to find the errors in the individual measurement, and you are also asked to find the most accurate value also. So how do you find the most accurate value from among these given values? Yes, the value having minimum numerical value, no matter either it is in negative direction or it is in positive direction, that is whether the sign of the error is negative or the sign of the error is positive, no matter, it doesn't matter. Here we just have to consider the numerical value. So which of these measurements, which one among these measurements have the least value? We can say 0.04. Yes, this one, isn't it? 0.0321. 0.0321 is the minimal difference. Among all these differences, among these four differences, while finding the most accurate value, we only consider the magnitude of the difference. We will never consider the sign of the difference. Is it clear? So I have to find actually the least value among these four values. So among these four values, 0.0321 is the least value. So we can say this is the most accurate value. 11.9679 is the 11.9679 is the most accurate value. Is it clear, guys? Yes. Suppose you are also asked to find the possible precision of the ammeter. Not the precise value, not the most precise value among the given measurements. You are asked to find the precision of the instrument ammeter. Yes, how do we find the precision of an instrument, of any instrument, from the given values? If you are given a set of values and you are asked to find the precision or the possible precision of the particular instrument, how do we find? Yes, we just go through the given values and we will find the maximum number of decimal places. We will find the maximum number of decimal places from the given value. In the first value we have 2 decimal places. In the second value we have 3 decimal places, and in the third value we have 4 decimal places, and in the fourth value we have 3 decimal places. So the maximum number of decimal places given in these exact measurements. All the given measurements are exact measurement. It is not given in a range. They are given. All these given values are not given in a range, but you are provided with exact measurement. So the maximum number of decimal places in this exact measurement is 4. So using this ammeter, yes, it is obvious that you can measure exact values. You can measure exact values up to 4 decimal places from these given measurements, isn't it? So we can say the precision of this particular ammeter is 0.0321. 0001. That is, using this ammeter we can measure exact values up to 4 decimal places. Possible precision of the instrument of the ammeter is nothing but 0.00001. This is how we find the possible precision of any instrument from the given measurements. Here guys, accuracy, precision and error and these example problems. Yes. So now let's move on to the next topic, types of error.